Wow, this is so exciting. One of the last talks of such a great conference. So thank you all for an amazing 4 days. Do you ever get the feeling that Shiny has stopped being just a simple tool for interactive data visualization and that people now want to build like real large business applications in Shiny and put them into production? I do, and I think we had, like, during this year's conference and presentations about Shiny, we had lots of great examples of that change that is happening in the Shiny world and that whole shift. My name is Marek Rogala. I'm CTO at Epsilon Data Science. So we do a lot of data analysis, machine learning, but also a huge amount of our work is Shiny applications development and consulting. So what our users expect from web applications and from our Shiny applications now differs dramatically from what was just a few years ago. They expect their data to be saved automatically so that, whenever you make some changes, close your app and then open it again, your data should still be there. And also they are used to interactive live collaboration, like in Google Docs, for example. And also they want the solution to be delivered as fast as possible, of course. So the thing is that they don't care whether this is a simple thing, simple app from a single data scientist or a solution delivered by a team of software engineers. But can we actually provide this kind of experience in Shiny without a ton of hacks and a huge amount of work? I hope to convince you that we do. And from this presentation, you will learn how to add data persistence and live collaboration to your Shiny apps easily. And also, I'm going to show you a package that we created that makes it very easy. But before we get into the package thing, let's first start at the conceptual level. So what do we need to provide this kind of experience in your application? So probably we need some place to keep your data in, like, for example, a database. And ideally, not just a database, but a reactive database, like Firebase, that was mentioned just a few minutes ago. So what is a reactive database? Well, to put it simply, in a traditional database, you make a query, you get the result, and that's it. Your query is finished. So you have to make another query if you want to get an update. Now, in a reactive database, you make a query, you get the initial set of results, and then as your data in the database changes, you get updates that, for example, some document was added or deleted from your result. So we can use this not only to keep our data, but also to update the application state for all our users immediately. So so examples of such databases are RethinkDB and Firebase, and also MongoDB, which is technically speaking not a reactive database, but it's widely popular and it can be used in a similar way. In this presentation, we will focus on RethinkDB, but exactly the same idea applies to any kind of reactive database. So how can we connect to RethinkDB from R? Well, there's a package for that, obviously. It's called Rethinker, and it simply exposes RethinkDB's API in R. And so basically, you make a query, and you provide a callback, which is a function that will be called by the package each time there is some update to your result. Now, this works, and works pretty nice, but in our experience, it was quite painful to use this directly from Shiny. First of all, there were some non-obvious things to get right for this actually to work. And most of all, using callbacks does not really play that nice with Shiny's reactive paradigm, right? It would be so much nicer if we just made a query and got a reactive in Shiny that will be updated when there is some change, and we would just let Shiny handle updating all the things that depend on our data. And this is exactly what the package I want to show you solves for you. So the package is called Shiny Collections. And what it does, it lets you easily connect to a collection in RethinkDB from your Shiny app. And, wow. And basically, you get the result as a reactive in Shiny. So, that's fixed. Yeah, so let's see how this works. Actually, I'd like to show you a live demo. So we're going to build a simple chat application in Shiny. And thanks to this package, this will be just a few lines of code. All right, so we will start by loading some libraries. Can you see the text? Isn't it too small? Maybe let's make it a bit larger. Yeah, so we'll just load some libraries. And now let's create some simple UI. So let's have some title, then a username field so that you can tell who you are. And now, not this one. And now a message field, so to input what you want to say. And now just a send button. Cool. So let's see what this looks like. Yeah, so as you can see, a very, very plain, very simple UI, but this will be just exactly what we need. All right, so let's now get this to work. So the first thing we need to do is to open a connection. So we use the connect function from the Shiny Collections package. So you basically provide the address of the RethinkDB server and also a name of the database. And that's it. We've got the connection. It's properly configured. So this function takes care of all the tiny things that you need to do for everything to work smoothly. And now that we have the connection, let's use another function from the package. So this will be a collection, the function collection. And what does it do? It basically creates a handle to a collection in the database. So you provide the name of the collection and of course the connection variable. And you can also add some filters here, but we won't need that. So basically this returns a handle to the collection, and what you can do with this handle is you can see what's inside the collection and also makes changes to this collection, like add some documents, modify, or delete from the collection. All right. Cool. So let's now add some way to send messages. So we will just observe the send button, and whenever it is clicked, we will run some code. So whenever the send button is clicked, we will just take the username, the message, and also the current timestamp so that we can order the messages afterwards. Okay, so we have that. Let's insert this into our collection. So the collection is called messages. We have the handle that we just created, messages, and we simply call the insert function. And let's also clear the message field, the message input, so that we are ready for your next message. Okay, great. Yeah, so we are almost there. The last final thing we need to do is to display our messages. So let's go back here. Let's add some UI output. And now we just need to fill this output in our server function. So we'll need a render UI block, and now what we do here is we use our handle to the collection, and we call $collection. And what this does is it simply returns all the documents inside it. And the thing is that this value is reactive. So whenever there is some change to our collection, to our data, this whole render UI block will be rerun, and our messages will be updated. Cool. So we will arrange the messages by time, because this is a NoSQL database, and they were not ordered. And now we can just add some formatting code, so some HTML, nothing really special. Okay, great. So let's now see if this actually works. So I'm going to open 2 windows to simulate users on 2 different machines. So one will be Marek, the other one will be Olga, and let's chat. Hi, how did you like useR 2017? It was awesome. Yeah, so this worked. And as you can see, it was like under 50 lines of code. Under 50 lines of code. And most of this was UI code, by the way. Right, so this is a very simple example, but the whole mechanism is actually quite powerful. You can easily integrate this with components like DT data table, leaflet, R-hands-on table, whatever you want. And actually, one last example I'd like to show you is an example of a larger application built in this way. So let's stop this one and start the other one. So this is an example of an application that we have built internally to manage project resources allocation, something like that. So basically what you can see here is that we have some projects, some clients. You can define different scenarios and compare them. But what's interesting here is that all these tables are connected to the database and persisted. So you can just close your window and open it again, and you will not lose your work. And you can also collaborate. So yeah, I can input something here, and it will appear here. So we're actually using this to do resources planning while being in offices in 2 different cities, and this works pretty nice. Yeah, so this is possible. So the package is available on GitHub. You can install it from there. Contributions are very welcome because this is quite an early version. Bug reports and feature requests as well are very welcome. And the goals for the package are releasing it on CRAN and also extending the API to allow like a more diverse set of features and operations on the database. So Shiny Collections gives you a way to add really nice experience to your application. It handles data persistence and allows for live collaboration. It's very easy to use and integrates with all popular UI components. And if you want to build great user experience in Shiny apps, use Shiny Collections. Thank you.
Thank you, Marek. Do you have any question? Okay, no more question. But if you want, you can talk with, you have, okay.
Right. No, so right now this was not a problem for us because this was like pretty limited usage with didn't have any application that we put like to anyone on the internet. And so no, we didn't have that. But this might be necessary if you just put the application in the wild. So the question was, is there any throttling support so that when someone like makes a lot of queries and a lot of just tries to make a lot of operations, will the server be overwhelmed, or can we throttle that?
Okay. Another question? Okay, thank you. Okay, you have one.
Yeah, so the question was, do we manage conflicts? Like when two people want to change the same cell, what happens in that case? So basically we are using now the conflict resolution in the way that the last change wins. So it's a very, very basic conflict resolution. So if two people make the same change at once, like the last change will win. Yeah. Yeah, so the question was, can you, for example, highlight a row so that you know that someone else is editing this row? And this is entirely possible. Like, we don't have any special support for that, but you can definitely just implement this in using this mechanism.
Okay, thank you.